Activity 5. To study the nature and size of the image formed by convex lens and concave mirror on a screen by the candle and a screen. The first thing, we are going to take the convex lens. Instead of using a candle in our activity, we are going to use a lamp box. So we are going to use lamp as a source, light source. So before we are going to start this, we should know that the convex lens, what is the focal length of convex lens. So this activity is primarily, it is used to analyze what is the nature of the images formed by and the size of the image formed by the converging lens and converging mirror. So to study the converging lens and mirror is this activity. So first we are going to converging lens, that is convex lens. The convex lens will be like this. So bulges at the middle and thinner at the edges. First we are going to find that what is the focal length of convex lens. So I am written here, it is a focal length is 21 centimeter. But this is not given in your examination, practical examination. We have to find the focal length of the convex lens, rough focal length of the convex lens by distance object method. Dear students, this is a lens stand, convex lens and a screen. So I will focus the distance object on the convex lens. The distance object is in our lab. There is a distance, long distance is there is a in your bottom in the wall there is a small window. Okay, the trees and windows are seen. So that thing we are going to focus by using the convex lens. So we are able to see by adjusting the lens. So we come to we are able to get the clear image of the windows, and these things. So are you able to see this? This is the window with the trees and everything. If you are seen in the naked eye, means it is easy for you. Through camera, it is not possible for me to focus clearly. So this is a clear image. So we may, if I adjust the lens, what is that? The image is blurred. If the lens is too closer, image is blurred. So I adjust the lens. Adjusting this lens. Okay. So by adjusting this lens, I am able to get the clear image on one particular point. The distance between the screen and the lens is a focal length, because the parallel rays falls on the convex lens. The convex lens converges the rays and forms a real and inverted image on the screen. So what is the focal length? So initially the screen and the lens distance at clear image position is, so it is exactly 21 centimeter. It is exactly 21 centimeter. Dear students, after finding the focal length of the convex lens, you are very familiar with this tabulation. This is the object position, this is the image position, size of the image and the nature of the image. So this is the first thing we have done that. So at infinity, what is the focus? The focus is formed at 21 centimeter. So from this we found that the focal length of the convex lens is, so that image is highly diminished, very diminished image, point size image. The big trees are appear as a very small image. Next one is beyond 2f. So f is a 21 centimeter. Beyond 2f means the object distance. The distance between the lamp box and the lens is greater than 42 centimeter. That is 60 centimeter. Here instead of candle we are taking the lamp box. Here I pasted the half portion. The half portion of this lamp box is covered with white paper. So we have to identify whether the obtained image is real and inverted or not. For that purpose I am doing. So the first position is beyond 2f. Beyond 2f means the distance between the lamp box and the screen is greater than 42 centimeter. Here I pictured as a 60 centimeter. Then there is another scale which is kept at 0 at 60 centimeter. That is the distance between the lens and the screen is V. The distance between the source, lamp box and the lens is object distance U. So the U is 60 centimeter. What about the E? By adjusting the screen, I am able to get the clear image at the point. This is a second scale at the point 31 centimeter. So U is object distance is 60 centimeter and image distance is 31 centimeter. Don't see this 91. So this is exactly second scale only. We have to take it as a B because from 0 is started from here 31 centimeter. So what is the image? You observe that. So there is a upper half circle. We are able to see that. But in object, what is that? That image will be closed. Here the upper half circle. I will switch off that. So are you able to see this? So upper half circle is closed. The upper half circle is covered with white paper. So the image is, we are able to see that bottom half circle is closed. So I will show the image now. So this is the object. So the image, what is that? The lower half circle is closed. But in object, upper half circle only closed. So this is proof that the image formed is a real and inverted image. Next thing is, when the object is kept at 2f means 21 into 2, 42 centimeter, image is also formed at 22 centimeter, but the size will be same size. In previous case, the size is a very, very smaller, diminished image. In this case, the size will be same size. Yes, this is a object distance from the lamp box to the lens is kept as a 42 centimeter. From the lamp lens, there is another scale is kept at the distance of 42 centimeter. We are getting a image. That image is just slightly bigger than the previous image what we are kept when the object is kept between the beyond 2f. So this image size is equal to size of the object, that is same size. So the nature of the image is real and inverted. We are identified that one because of the lower half circle is closed, but in object upper half circle is closed. In object upper half circle is closed, only the lower half circle is open. So we can found that the image is real and nature of the image is real and inverted and the size is same size. So similarly we can put for the object is between the f1 to f1 means 30 centimeter, we get an image at 61 centimeter. The image is enlarged. Yes, we can see that this is a lamp box. So from the source to lens, the distance is 30 centimeter. So exactly it is 30 centimeter. It is exactly 30 centimeter. Then from the 30 centimeter, what is that? Beyond 2f means, what is a f? F is a 21 centimeter, beyond 2f means greater than 42 centimeter. So the lens is kept, the object distance is between f1 to f. F is a 21 centimeter, then 2f is a 42 centimeter. Between means we kept it as a 30 centimeter. But the image will be formed where? It will be formed at beyond 2f. That is, we are getting the value 61 centimeter. Now you see the nature of the image. The nature of the image is real and inverted because the lower half circle only closed, but in object upper half circle will be closed. The wire gauge upper half circle will be closed. Then what is the size? So compared to the previous one, the size of the image is enlarged. The wire gauge will be look bigger and bigger. So in this way, by adjusting that, first you have to calculate the focal length. So the focal length can be calculated by using the first topic. When the object is at infinity, distance object is focused means we get a focus that is a 21. By using this calculation, you have to do that experiment, that is activity, by adjusting the values. So 60 centimeter means beyond 2f. 2f means 42 centimeter. Between f1 to f means 30 centimeter. Correspondingly, we get a distance which is obeys with the theoretical value. And also, when the object is kept at f, what will happen? The image is formed at infinity. We cannot catch that on the screen. That is, we are not able to prove in this activity. That is practically not possible. Then between F and O, the size, the image will be formed on the same side. The nature of the image is visual and erect. The visual image is an image which does not cut on the screen. That also we are not able to prove in this activity. But we can explain in this activity by drawing this tabulation with this calculation. So you have to write these readings in the activity examination. So only one part is we are completed. Convex lens only completed. Now we are going to, in the next part, we are going to study detailedly about concave mirror, nature and size of the image formed by the concave mirror. So dear students, first memorize this tabular column, then you have to do the activity very clearly. The YOY's questions will be asked. What is the size of the image? What is the nature of the image? What will happen when the object is kept? These two things, all those things. In this activity, only thing is, instead of candle, we are using a lamp box. In order to identify the nature of the image is real and inverted, we are closed the upper half cycle of the upper half of the wire gauge. Only the lower half is opened.